We can also combine this too. We can say that ln of st divided by so equals negative v max km t. I'm going to raise both sides to the e power, which means that this is now going to become st divided by so equals e to the negative v max over km t. And now we're going to get st equals, I'm multiplying both sides by so e v max km t. So this is the integrated equation. Dr. Gassier, if this was kind of confusing, a little fast, Dr. Gassier did do it in class, so you might want to review your notes. And hopefully this isn't too confusing of how I came about this equation. So what we will need to do is that now that we have a initial substrate which was given to us, so the question again is saying with a km of 2.6 times 10 to the negative third and an initial substrate of 2 times 10 to the negative fifth, and we figured out our V max, what would be the product concentrations after 5 minutes and after 10 minutes? Okay. So what we're going to do is we're going to do this. St equals 2 times 10 to the negative fifth e raised to the negative V max over km times t. T is going to be 5. Km is 2.6 times 10 to the negative third. And our Vmax was found to be the velocity, which is 5.9 times 10 to the negative fifth. Sorry, it's kind of hard for me to see what I'm writing. 5.9 times 10 to the negative fifth. It's a lot of shadow, and so sorry about this. But basically what this is this is negative negative 5.9 times 10 to the negative fifth divided by 2.6 times 10 to the negative third times 5. And that's going to give us our ST. Again, Vmax equals our velocity when the substrate was a much greater than Km. Something that's very important. The hardest thing about this equation in number 6 is knowing what assumptions that you can possibly make. Okay, so I'm going to go ahead and do these calculations, and then after this, actually what we're going to get is we're going to get PT, which is the actual what they're looking for, is going to equal SO minus ST. So I'm going to go ahead and write this all out, and I'll be back with the answers. Okay, so I'm back, and what we do have is we have ST is equal to 1.79 times 10 to the negative fifth, and then we plug in our original S0, which is our original substrate, and now our newfound ST And this is what's going to give our products of 2.15 times 10 to the negative 6. Okay, so I don't think I need to do part B, because part B is just replacing this 5 with a 10. Okay, so I hope this helped out. And if you have any confusion, please review your notes of how to actually integrate this, which is something that was went over in class. And also the ending of part 2 of number 6 is going to be a little bit more clear on how this integration works and why we did this. I kind of had to do this fast just so I could get it out to you because YouTube doesn't let me go over 15 minutes. So sorry about that, but this is how you do the equation, the problem.